Okay, we are going to be talking about section 5.6, definite integral substitutions and the area between curves. Okay, first thing we are going to cover is substitution rule for the definite integrals. We are going to assume that we have two functions. We have the composition of the two functions. I want you to see this integral expression here. We have an integral from a to b. We have f and g composed and multiplied with the derivative of the inside function times dx. Whenever we see such a situation in an integral, there is an easier way to handle this integral. We are going to convert this integral in x to an integral in u. We could do that by just letting u is equal to g of x. When g is u, then this becomes f of u, and g prime x dx becomes du. And then the limits are going to change, because whenever x is a, u is going to be g of a. Whenever x is b, g is going to be u is going to be g of b. So the limits are changed, and this integral that we find is simpler than this integral, and it's easier to integrate this one. That's why we do the substitution in definite integrals. In order to do that, we have some, of course, conditions, like we assume that the g here is differentiable and the derivative is continuous on the interval ab and closed interval ab, and f is continuous on the range of g. We have this assumption, these two assumptions. Before I continue, I want to solve some problems here. Okay, we are going to start with the substitution rule. These are my previous lecture notes from fall 2009. Here we give the substitution rule for indefinite integrals. Okay, u is again g of x. It's a differentiable function. It has a range. The range is an interval, and f is continuous on this interval. Then integral f composed g times g prime x dx is equal to f of u du. As you see, this is the composition of two functions, and this is the g prime x dx, which is the derivative of the inside function. Let's give some examples. I have, I think, 5 examples here. You can see the examples here. In the first example, I have the composition of cosine and x to the 4 plus 2. In the second example, I have the composition of square root and 2x plus 1. In the third one, I have the composition. You see the square root of 1 minus 4x squared, which is the composition of square root, and 1 minus 4x squared. And in 4 a little bit kind of difficult, but we are going to talk about that. And here you can consider square root of 1 plus x squared is a composition of the 2, square root and 1 plus x squared. And in the fifth, the composition of cosine and 5x here. You can see that we can use substitution to make things easier. Now, the solution to the first. Now, first thing you observe, as I said, this is f composed g, this one, and the inside function is x to the 4 plus 2. When you take the derivative, you should see that it's going to become like 4x cubed, which we have here, x cubed. So, substitution works here. U is going to be x to the 4 plus 2. Take the derivative, du is equal to 4x cubed dx. And then divide both sides with 4. Okay, so as our substitution says, u is equal to x to the 4 plus 2. Du is 4x cubed dx, we said. And du over 4 is x cubed dx. These are the steps that you have to do. And then we are going to substitute what we have here. As you see, x to the 4 plus u is u. Cosine u times du over 4. This is easy to integrate. The antiderivative of cosine is sine. Keep the 1 over 4 in the front. And don't forget to write plus c here, because this is an indefinite integral, right? So the answer is then 1 over 4 sine. Instead of u, we write x to the 4 plus 2 plus c. And this is the final answer. Next, my second example. Integral square root of 2x plus 1 dx, and as you see, this is f composed g. Here f is square root, g is 2x plus 1, and if I let g to be u, Okay, so as we said, f composed g is square root of 2x plus 1, and it's going to turn out to be f of u, and 2 dx is going to be du. Okay, so the substitution u is equal to 2x plus 1 works really well, and we get du to dx as we said, and we put it in 1 over 2 integral square root of u times du. And this is just a power rule. You apply the power rule and you get the answer as 1 over 3 u to the 3 over 2 plus c. Don't forget to put c at the end. And then substitute u as 2x plus 1. And we get the final answer as 1 over 3, 2x plus 1. Raise it to the power 3 over 2 plus the constant c. Okay, next one is the third example. As you would see, we would let u to be 1 minus 4x squared, and then f is going to be square root of x, g is 1 minus 4x squared, and we take the derivative of u, we get du, it's equal to negative 8x dx, and negative 1 over 8 integral du over square root of u, it makes, because negative 8x dx is du. Be careful here, there is a right here, if you see the cursor, we have negative 1 over 8 trick. We have this trick, okay, because we want to get negative 8x, so we multiply and divide by negative 8 both sides, numerator and denominator. We just multiply by negative 8 and negative 8. Okay, and on page 18 we have negative 1 over 8 integral du over square root of u. This is again power rule. We apply power rule, then we substitute what u is, and that's the final answer. And in question 4, this is kind of a little bit harder than the previous ones. And we have here square root of 1 plus x squared times x to the 5. And if you say 1 plus x squared is u, we get 2x dx as du. However, we have x to the 5, so here you do this trick. X to the 5, you just write it as x squared times x squared times x. Then it's going to work out well. We have the substitution u is equal to 1 plus x squared, du is 2x dx. And by multiplying and dividing by 2, we get 2x dx here, which is going to be du. And for x squared, it says it's u minus 1, and square root of u. Okay, so this is nice. And you can, this is a polynomial, you can just, u minus 1 squared is a polynomial. You can open it up, and then you can multiply this with square root of u, and everything is in powers. So, like in here, you distribute u, square root of u over here, and everything is in power. Apply the power rule, and don't forget to add c at the end, and then substitute back what u is instead of in terms of x, and that's the final answer. Question 5 is integral cosine 5x dx. Cosine 5x, this is like f of u, where u is 5x, and then if you take the derivative of 5x, you get 5 dx. So we have 5 extra here, and then we divide by 5 and multiply by 5. The value doesn't change, the value of the integral. We got 5 dx is du, and 1 over 5 integral cosine u du we get, and antiderivative of cosine is sine u. Don't forget to put c plus c at the end, and write back in what u is, and we get 1 over 5 sine 5x plus c. And substitution rule for definite integrals we mentioned in the slides. So that was the statement. If you have the endpoints a, b, then you're going to convert it to endpoints in terms of g of a and g of b, and you're making the substitution u is equal to g of x, and integrand becomes f of u du. Yeah. Now, how would you apply this? I have two problems solved. If evaluate the given integrals. First one is 0 to 4 square root of 2x plus 1. This is familiar to you, and we have f is square root of x and g is 2x plus 1. G is u, and then as you will see in the solutions, this is f of u. This is, look at the red colored written parts, f of u du, where u is 2x plus 1, du is 2 times dx. And then the endpoints, limit points, are going to change to 1 to 9 because why? X is 0, you put in u is equal to x plus 1 and you get u is equal to 1. And x is 4, you put it in the substitution, you get 9. So 1 to 9, 1 over 2 integral 1 to 9 square root of u du is going to be 1 over u. This is the power rule, apply the power rule, and you get 26 over 3 as a solution. Be careful here, you don't have to put back in what u is in terms of x because everything is in u now, so forget x afterwards, okay? For the indefinite case, we convert it to x. For definite integral, we don't have to. Second example, 1 to 2 dx over 3 minus 5x squared is equal to 1 to 2. Now here we have 3 minus 5x is u, and then du is going to be negative 5 dx. Since we don't have negative 5, we multiply and divide with negative 5, the integral, and then we get negative 5 dx. And then we are going to put in the u value, so we have negative 1 over 5 outside, and d over u squared comes from here, 3 minus 5x is equal to u. We have that u squared coming from there, and then the limit points are going to be negative 2 to negative 7. The reason is explained down here. Whenever x is 1, u is negative 2. Whenever x is 2, u is negative 7. And you put back in, you integrate of course, and it's power rule, and you put in the values of u, and the answer is 1 over 14, and that's the final solution to this. So that's the end of the lecture about substitution. We will continue with the next topic in the next video.